So let's look at dropping something into a moving railroad car. I guess I could put railroad tracks underneath there to make it more of a complete picture. So my car is moving along this way, and it doesn't have a velocity of 10,500 kilograms. It has, has a mass of that. It has a velocity of 15 meters per second. I think I did too many of these in one day. All right, so it has an initial velocity of 15 meters per second, and that's its mass. The mass of this thing being dropped into it is a 6.35 kilograms, and the velocity is kind of coming on down this way. So this one is, as far as our Y components go, I look at this and I'm like, whoa. Well, the only thing moving in the Y initially, let's call this A and this B, is, let's see, mass A, velocity A equals, what's happening there? Because this thing is moving along this way. So what do you think has happened here? Let's take a look at the X. I have, whoa, this thing's not moving in the X. I only have velocity here. So I have mass B, velocity B. Let's define that way as positive and just go ahead and just say down. Equals, well, in the end, they're combined. It's mass A plus mass B times V prime of the combined system. So if it wants V prime, then it just becomes mass B, velocity B, divided by the sum of the masses is my V prime. So I can write that out, that I have my mass A, 10,500 kilograms times its velocity of 15 meters per second divided by the sum of the masses, so 10,500 plus 6.35. And let me ask you this, can I cancel out these 10,500s? The answer is no, because this is a sum down here, not a product. So those masses don't cancel out. So let's see what I get as a final velocity. 10,500. See, he's excited to hear what I get. Times 15 divided by 10,500 plus 6. That is 6.35. 14.99. Oh, didn't slow down much. Of course, I wouldn't expect that it would, really, because this thing is pretty darn massive, and I'm only putting this 6.35 kilograms. So what happened to the rest of that speed? Well, that little extra, well, that's just the combined masses slowing it down. What happened in the Y? Because here we need to be comfortable saying that this is like taking it in the Y. If I extend this system to be like the mass, the universe, and everything, that there's going to be a teeny tiny little wiggle in the universe that kind of balances that out. That's what everybody says. You can run with that. Or you can look at it and say, well, there is no motion. This railroad is stopping that motion in the Y. So this thing called energy that we're going to talk about, that I have lost some energy, I have an external force kind of acting on this thing, not allowing motion in the Y. Because if it did, then the railroad car would fall down, which would be awkward for the railroad car. So this whole thing is just, it's a non-conserved quantity. There we go.